Hi guys, this is Karthik. So in the last video I discussed some of the good project ideas and I said if you are not aware of a lot of different technologies like Angular and you don't know web development, you don't know Android development, but you still need to have some good projects in your resume. Otherwise, how will you prove your skill? So I told you guys that okay, let's make some libraries for data structures and the prerequisite for that was very small, just knowing one general purpose programming language and knowing a few other things like data structures, algorithms, and you're good to go, right? So that was a good project idea, but still, even making libraries for data structure requires a lot of good development skill, I would say. And for a complete beginner or even for some people with basic understanding of C++, Java, and basic understanding of DSA, writing libraries is a hard task. So in this video, the aim would be to teach you guys how you can write libraries. The aim is not to give you a ready-made project for you to write in your resume. The aim is to help you guys how you can write libraries and what is the right way to go if you are thinking about writing a library for some data structure. And my recommendation is that you should definitely write good libraries for graph is a really good data structure for which you could make libraries. And honestly, if you make a good library, people would even like to use it for their a lot of tasks, like even for development, for competitions. So that's a good idea. You can go ahead and make a graph library. But in this particular video, I'll be discussing a good library for dynamic arrays. Now, what are dynamic arrays? So usually by default arrays are static. Once you've declared an array of size x, it stays of that particular size x. Arrays cannot be resized, okay? And a workaround for that in C++ is vectors. In Java there are array lists, but by default arrays are not resizable, and it is a very interesting quality for the us to be able to resize. Now if a person is a developer, they would not like to make a dynamic array class for themselves every time. They would like to use good quality libraries that are already made. So currently the libraries for this particular purpose are already there and they are too good to beat. But to get started, you need to learn the basic stuff first. So I'll be showing you how you can actually implement libraries, and we'll be implementing dynamic arrays or a vector kind of class. I would not implement the way vector is actually implemented. It would be close to that, but it won't be as efficient. Asymptotically, of course, I will try to make it as efficient, but runtime wise, it's not possible for junior developers like us. Those libraries were made by really brilliant people. Okay, so but we'll try our best and we'll learn something new. So let's get started already, guys, and hopefully you will find this video very helpful. So guys, whenever you are trying to implement a library in C++, you need to have a .h file and a .cpp file. It's not actually required, you could have them both in the same file, but it's recommended that you make a .h file and a .cpp file. Then the person using a library could say, okay, hash include vector.h, right? So that's how it goes. And in the .h file, you would specify the things that you're going to give to the user, the functions that could be given to the user. This .h or the header file would work as a contract between you and the user, okay? And this .cpp file included with this .h file would actually provide implementations for these, okay? For now, let's just go ahead and implement the .cpp file. For this video, I would like to make things simple and we'll just implement .cpp file. It's quite easy and you can go online and search how you could make two different files and keep your implementations and declarations separately. In fact, you could even check out my GitHub. I usually make two different files. Okay, so let's start making our class. We'll have a class named vector that is going to provide us the functionality of resizable or dynamic arrays. I'll name it vector with a capital V. Okay, and we don't know anything about the actual vector class, otherwise there's no point, right? So we'll be implementing it using raw pointers and raw arrays that are given to us by C++ by default. Okay, so now I will think about the features that I would like to provide my user. Since it's an array, what are the features that could be given to the user? First of all, the user must have the ability to add an element to the vector, maybe. Of course, that thing must be there. So the features that I'm going to give to the user, I'll mark them public because the user must be able to access them. And guys, by default in oops, try to hide as much as possible. You should give least access to the user. If something is not required by the user, you don't have to give access. um, I guess you guys would enjoy it more if you're able to see me also. Okay, so I guess it feels better. Tell me in the comments if having the webcam on or off makes a difference. I usually try to keep it off because the quality isn't that great. Anyway, so I would like to add elements in the vector. Of course, that's an important feature. I would like to access elements, access the ith element, etc. I would like to make a vector, of course. So initialization of the vector using a few elements or no elements. But of course, you would like to have some default constructors. So constructors, and yeah, let's start with this much. We'll see later on what else we need. So I will need some constructors, of course. So user may declare a vector. Now guys, important thing here is that you are not happy with just vector of integers, you are not happy with just vector of doubles, you need vector of any type. So I will say template class t. This allows the user to pass a particular type t, and then the compiler will automatically generate a class vector that is parameterized by this particular type t. So wherever I type t x, this means an object of the class t, and this t would be given to us by the user. So if t user passes int, this would mean integer x. If user passes employee, this would mean employee x, and you could have a list of employees, something like that, right? So I have templated my class with the parameter t. Okay, so I would like to create vectors. Okay, and I'll have a constructor to do that. I would like to have one more constructor where the user could actually pass an array of this kind, and I could initialize my vector by using the elements of the array passed to me. So let's say the user passes this array and tells me the number of elements in the array. We'll be implementing this. Okay, two constructors are enough. This is a default constructor that just gives you a vector with no elements inside it. This is a constructor parameterized one which gives you a vector and initializes it with the contents of this particular array. Sounds good. Okay, and yeah, so we can declare vectors now. We need to have some container to contain this particular vector. So of course I'll be using array. That's what a vector does. It uses array underneath. So let's have an array. What type of array? An array of class t type, right? And I won't have an array, I will have a pointer. Currently I don't know the size of the array, I cannot actually initialize it. Initializing it with a very large value is not good software development practice. You waste a lot of memory. So I initialize it with t. So now the user passes int, it's int star ar. User passes employee, it's employee star ar. Okay, so I have this ar, I'll name it data. So if it's a default constructor, I don't have anything to store, so why waste memory? Simply initialize data to null. If I have something to store, I would need at least that size. So I'll say okay, let's make an array of the size. Of course, user has to pass an array of type t. So I'll make an array of size n of the type t. I'll copy the contents of this array into my data array and I'm done. So I can say go through this array and data at I becomes ar at I. This means that t, my class t, needs to have a assignment operator overloaded. Data I equals to ar at I, and we're done. We have initialized our vector. We are happy, user is happy. Let's see what all other features we'd like to provide to the user. Am I missing anything in this one? I don't really think so. Okay, we can move ahead. We'll see if we need any more variables or personal bookkeeping data. We'll see to that later. But let's see what more features I want to add. I would like to add elements, and since this is a beginner tutorial, we'll be adding elements to the back. Okay, I'll only add to the back. I'll name the function pushback. How creative of me. And I'll say that pushback returns nothing. It simply takes an element from the user, it adds it to the back of the vector. Let's say t item. Let's pass it by reference. Yeah, okay guys, whenever possible try to have constant stuff. This is very useful. Why is it useful? I will maybe tell it to you in some other video or maybe in the comments. For now I am not going to use this kind of good practice, but always and always whenever it's possible to have something passed by passed as constant, you have to make it constant. This provides the user a guarantee that if the user is giving you some data, you won't be touching it. And when you actually go to software development, this is an important thing for the users. The user might not want their data to be touched. Okay, for now we are not that good developers, we'll keep it simple. So I need to add an item to the back of my data, but my data is a fixed size array. Data points to an array that is a fixed size. What do I do? So what I can do is I could create a new array of size n plus 1. If my current size of the array is n, I could make a array of size n plus 1. I could copy the entire data into the new array and I could place this element at the end. This is not what the vector does, it is much smarter, but let's go for this for now. So I'm declaring a new array of size great plus 1. So I'm saying t star, let's name it temp, equals to new t. And what should be the size here? I need to know the size of my current array. So let's have a variable integer size. Okay, and here I can say size is initialized to 0, and here I can say size is initialized to n. Okay, now I'll be having a new array of size plus 1. I can simply copy the entire contents of the current data, okay, and I'll say temp equals to the current vector I had. I copy the ith element of data into temp, and finally now I have a size plus 1 temporary. This new array is plus 1 size, so at the end of it I could add my new item and user is happy, I am happy, we are done. This is very inefficient. Whenever you add a new element, you need to create an entire new array, you need to copy all the elements, so this is not efficient. The better way is what vector actually does. Let's keep it a suspense for one more minute before I do some extra stuff. So I need to delete my current array, so delete AR. I need to be smart about deleting the array if AR equals to null, if data equals to null, sorry. So you delete this. Okay, if there was anything that data was pointing to, any array, then you delete that, because you need to free up the memory. If you don't free up the memory, you are rejected in the interview. I can guarantee. If you don't free the memory and you are writing a library, I can guarantee that you are rejected. And in my try data structure, I know that I haven't done that, so I need to fix that too. So you need to free the memory. This is very important. I promise this is very important. Okay, so if data equals to null, you free the memory, and then you can say okay, data equals to temp. We're done. Now what the vector actually does is, the vector takes your array, and if the allotted memory is done and you cannot actually add an element to the back of the array, it doubles the size. So every time this doubling operation happens, for the next lot of operations, your insertion is big O of 1. Here if you see, the insertion is big O of size, But if I double this thing, I copy it, for one operation it's going to be big of size, but from the next operation onwards it's going to be big of 1 because I already have the extra space I need and I could insert it. And only when this doubled vector fills, I will double it again. And that's how the vector actually works underneath. We can discuss about it more if you want, but for now let's have this thing only. With learning how to make libraries, you can take this code, make it more efficient, give it in the comments. It will be helpful for me and the viewers as well. Okay, so we made the pushback function. We are done with pushback. What else would the users like to have? Accessing the ith element, changing the ith element, that are necessary operations. Okay, so we have pushback. We might also want to have pop back, so let's implement that also, or let's not do that for now. Okay, now how do I provide this? How to access the ith element, change the ith element? For this, what I'm going to do is we can overload the square bracket operators, and that would make the thing very nice. Or we could simply make two functions, get and set. So let's actually overload the functions. So I can overload maybe, and I can say, I don't know how to overload. I'm going to Google it. As simple as that. How to overload square bracket operator in C++. Overloading subscript or array. No, I won't use this one. I don't like that particular thing. Let's see this one. It's just operator overloading. Anyway guys, this is very important in software development. You need to know how to Google. That is super important. So they are saying that it could okay, that's as simple as it gets. I just need to copy this and paste it. This returns me a reference to the ith element, and I could even set it, or I could just print it as I want. And instead of int, I would say t. And this is operator overloading. I'm overloading the square bracket operator, and I'll simply return data at I. This is index, so it will always be integer. Now if you see one thing, this I might be out of bounds. I could be less than 0, I could be greater than size. What does vector do to help you? It does nothing. It throws an exception. It makes your program go into segmentation fault. That's it. What you could do is you could help the user by giving a nice error message, and this makes your vector safe from out of bound access. And that is very simple to do. It's just one if statement. Check if I is inside the bounds, and if it is, then return. Otherwise you say that user, you are dumb, user, you are doing something wrong. You give a nice exception through it, right? These are the things you could do. For now I am not going to do anything. We're done guys. Let's test this particular class now. One last thing I'd like to do. Again, as I said, you need to free the memory, otherwise you're rejected in the interview. And once the vector is used by itself, it should deallocate the memory it was using by itself. I'm not going to leave it to the user to do it, because user cannot in fact do it. Since data is private, user cannot say delete data. It's not possible for the user. This is my responsibility. If I'm providing a library, I need to provide a good, robust library that does not cause memory leaks. If data is not equals to null, here's another mistake. I can delete if there is something, otherwise I cannot delete. So if there is something, then you delete it, and that's it. As soon as your vector goes out of scope, you delete the memory that you had, and you're done. One more thing I was always wondering whether my pushback is correct or not. It is not correct. I need to make size grow by 1, this particular variable. Otherwise, how will I keep track of my vector? Let's just test this much and then we'll see what else can we implement for the users. You could think of a lot of things that could be provided. Let me declare a vector. Oh god. And I can say vector int v. Does this work? Where is my build messages? Come on. I guess it works. Let me run it. Yep, it does work. So it does work, but that's not what we were looking for. Let's pass in an array. Let's say integer AR. Maybe 1, 2, 3, 4, and 2, 1. I'll say okay, vector v, and initialize it using construct a vector using this array, and the size of this array I'll give it to is as 3, 6. Does this work? It does work. Let me provide one more function. Let's the user needs to know the size of the vector, of course. So in this size, and this is easy to implement, return size. So I now I have the vector, and one good thing I'll implement is that C++ does not do. C++ does not help you do this. You cannot actually print the vector by just saying cout v. Let's do that. Feels good, would be helpful in debugging and many other things. So why not just have a good overload of this O-stream operator, and you could actually print out the vector. So that might be helpful. For now we have a vector. Let's try printing. Let's try printing all the elements of the vector. And I can say cout AR at I. This should work. So vector size conflicts with the previous declaration. Okay, cannot say size, but I can maybe say get size. Yeah, that should work. Build logs, build messages. Error cout was not declared. Of course it wasn't. So yeah, my vector does work. That's a good thing. At least it's initializing it. Let's try pushback. V dot pushback. Let's add 10. Go till 7. Or why not use v dot get size? That's why we implemented it. Non-const reference of type in star. Okay, I cannot have tm% here. I will have to provide two overloads. One is a reference one and the other one which takes by value. Otherwise this would not work. And hopefully you do understand that, because by reference, if I am passing, I cannot pass a constant. So I need to have two overloads. Does this work? I do not think it does work, because I pushed 10. It is showing me 6. That's not good. Why did that happen? I will be very sad. In fact, I am very sad. So temp at size equals to the item passed to me. Temp at I equals to data. Till here it was good. I added this item. If data was not null, delete data. That's cool. Data equals to temp. So this is weird. This should have worked. Let's try to debug it. That's the best part. Okay, I'll go back here. I'll try printing the item once. Cout item. Item passed is correct, but still there is some problem. T equals to new t size plus 1. This is good. Temp I equals to data. I copied the array correctly, and then temp size equals to this. Oh my god, I need to say v at I. Okay, that's done. Yeah, so this works. Pushback works. That's really good. And gate size also works. Otherwise, this loop would not have performed that well. So let's go ahead and do one last thing. Let's give the user a nice method. So instead of doing this loop every time, the user could say cout v, and this should do our work. So the way to do this is you need to know a little bit of object-oriented programming, and you could actually overload the OStream operator. So I would go online and say how to overload OStream operator. Uh, and there it is. It's very easy. So you declare your operator as a friend, and you simply implement it. We'll simply copy this thing. Okay, our distance d object. Instead, I'll have a vector t object here. A vector t passed by reference. Let's name it v. I hope you guys are following. If you have any doubts, you should definitely ask me in the comments. And guys, we're done. I should name this thing output. That's simply a syntax of overloading. If I do this 100 times and I try the 100 and first time, I would still be looking up the syntax. OStream does not name a type. Oh god. Okay, there has to be some header that I need to include. Let me just include bits. OStream. Do I still need to write std? So again, we'll look for the error. OStream does not name a type. So they say use std OStream and std iStream everywhere are the namespace, but we are using std. Then what's the problem? Did I overload this correctly? Okay, I got it. I did write an std there, but I did not write an std here. And we're done. Cout was not, of course, std cout. Yeah, so this should work, hopefully. No, it does not. Oh god. This went recursive. Tell me in the comments how it went recursive. Yeah, now this should do the trick, I guess. No, even this won't do it, or maybe let's try it. Yeah, so it gave me the vector in a pretty good format, except the last comma that I could have avoided by maybe going up to gate size -1 and then saying output Alright, so this is pretty good. Now the interesting thing is that instead of int, I could have had anything. I could have defined a class of employees and I could have a vector of employees. So this is the power of template and generic programming. And guys, this was just a basic idea, a basic tutorial for you guys to understand how you could use all this stuff and how you could come up with some good projects. So hopefully you will make some nice interesting projects using this idea, and I hope that this was helpful to you. Make sure that you like, share and subscribe, and let me know in the comments if you liked something, if you did not like something, if you would like to share something which could have made my code better, or something you would like to discuss with me. You can definitely write in the comments. Thanks for watching guys. Bye bye.